you ever wondered what makes a shooting star shoot across the night sky? These celestial spectacles, known as shooting stars, have sparked intrigue and curiosity since the dawn of civilization. They've been woven into the fabric of our cultures, appearing in countless myths, legends, and stories that span the globe. In some cultures, these streaks of light are seen as messages from the gods, while in others, they symbolize a soul's journey into the afterlife. They've been interpreted as omens of good fortune and signs of impending doom. These varied interpretations reflect our innate fascination with the unknown and our desire to make sense of the world around us. And while we've come a long way in our understanding of the universe, shooting stars continue to captivate us with their fleeting beauty. They leave us gazing up into the night sky, our minds filled with wonder and curiosity. Now, wouldn't it be interesting to dive into the science behind these celestial light shows? Contrary to their name, shooting stars aren't stars at all. Now, I reckon this might be a bit of a surprise to some, but the truth is, these celestial marvels are nothing more than tiny specks of dust and rock, known as meteoroids, making their dramatic entrance into Earth's atmosphere. Imagine this: a meteoroid, traveling at speeds of up to 70,000 miles per hour, collides with the gases in our atmosphere. The friction generated by this high-speed encounter causes the meteoroid to heat up and glow, creating that familiar, fleeting streak of light across the night sky we often wish upon. This is what we commonly refer to as a shooting star, or in scientific terms, a meteor. Now, you might be wondering about these terms I've thrown around: meteoroid, meteor, and perhaps you've also heard of meteorite. Well, they're all related, but each term describes a different stage of a space rock's journey. A meteoroid is essentially a small particle from a comet or asteroid, roaming about in outer space. When a meteoroid enters the Earth's atmosphere and vaporizes, it becomes a meteor. That's our shooting star. But what happens if a meteoroid is large enough to survive its fiery descent and reach the Earth's surface? Well, then it earns a new title: a meteorite. These meteorites, the survivors of a cosmic journey, can provide invaluable insights into the early solar system and the building blocks of life itself. So the next time you gaze up at a starlit sky and spot a streak of light darting across the darkness, remember, that's not a star making its grand exit. Instead, it's a tiny piece of the cosmos, a humble meteoroid, entering our atmosphere and transforming into a brilliant meteor before your very eyes. So, these fleeting streaks of light are not stars, but rather small space rocks meeting a fiery end. So, how does a space rock become a shooting star? Well, our story begins millions of miles away, in the vast expanse of space. There, amidst the cold and quiet, a meteoroid is born. These small rocky bodies are remnants from the early solar system, leftovers of the building blocks that form the planets. As they move along their orbits, these meteoroids are occasionally nudged by the gravitational pull of planets, primarily Jupiter. These nudges can sometimes send them hurtling towards our home planet, Earth, beginning their incredible journey as potential shooting stars. As a meteoroid hurtles towards Earth, it's traveling at breakneck speeds, often over 25,000 miles per hour. It's at this point the meteoroid starts to interact with the Earth's atmosphere, around 75 miles above the surface. This is where the real magic happens. Because of the meteoroid's high speed and the friction it encounters as it plows through the Earth's atmosphere, it begins to heat up. It gets so hot, in fact, that it starts to glow and vaporize, leaving behind a bright streak of light across the sky. This glowing trail of vaporized rock and metal is what we see from the ground, and what we commonly refer to as a shooting star. But it's not just a pretty light show. Every shooting star is a tiny piece of the universe's history, giving us a glimpse into the past and the formation of our very own solar system. The meteoroid continues to burn and glow until it either completely vaporizes or slows down enough to stop glowing. If a chunk of it survives the fiery journey and lands on Earth, it's then called a meteorite. That's the fiery journey of a meteoroid from space to our atmosphere, resulting in the spectacle we call a shooting star. Ever heard of meteor showers? They're like a grand performance of shooting stars. Picture our planet, Earth, voyaging through the vastness of space. Every so often we cross paths with the remnants of comets, and this encounter sets the stage for a spectacular celestial event known as a meteor shower. But what exactly are these comets? Comets are icy bodies that orbit the sun, leaving a trail of debris behind them as they go. This debris, made up of tiny bits of rock and ice, continues to orbit the sun in the same path as the comet. When Earth's orbit intersects with this debris trail, the pieces are pulled into our atmosphere. As they enter, they burn up, creating what we see as shooting stars. The occurrence of a meteor shower is not a random event, but rather a scheduled performance. Each year we can predict when Earth will pass through these debris fields, and thus when we'll see these showers. Some of the most famous meteor showers include the Perseids and the Leonids. The Perseids, named after the constellation Perseus, are visible from mid-July to late August each year. This meteor shower is known for producing a large number of bright meteors, often with a rate of 60 per hour at their peak. The Perseids are remnants of the comet Swift-Tuttle, which has a 133-year orbit. The Leonids, on the other hand, are a November spectacle associated with the comet Tempel-Tuttle. Named after the constellation Leo, the Leonids are renowned for their spectacular meteor storms. In years of peak activity, skywatchers can witness up to several thousand meteors per hour during a Leonid storm. So, the next time you're watching a meteor shower, remember that you're witnessing the remnants of a comet's journey around the sun. You're seeing pieces of space history burning up in our atmosphere, creating a light show that has been billions of years in the making. So, meteor showers are essentially Earth sailing through cosmic debris, giving us a magnificent display of shooting stars. So, how do scientists study these fleeting celestial events, you might wonder? Well, the science behind shooting stars isn't as mystical as the spectacle they create in the night sky. It's a blend of patience, technology, and a dash of luck. First off, let's talk about radar observations. Radar, short for radio detection and ranging, is a versatile tool that enables scientists to detect and track meteors, the scientific name for shooting stars, as they hurtle through our planet's atmosphere. By bouncing radio waves off these fast-moving objects, scientists can accurately determine their speed, direction, and even their composition. This is particularly useful for studying meteors that are too small or too fast to be seen with the naked eye. Visual observations also play a crucial role. Using high-powered telescopes, scientists can observe meteors in astonishing detail. They can study their brightness, color, and trajectory, providing valuable insights into the meteor's size, composition, and origin. But it's not just about looking up. Sometimes meteors are generous enough to leave behind meteorites, chunks of space rock that survive the fiery descent and land on Earth. These meteorites are like cosmic time capsules, holding valuable information about the history and makeup of our solar system. And let's not forget about the vast network of amateur astronomers and skywatchers around the globe. These dedicated individuals play a crucial role in capturing and reporting meteor sightings, contributing to the collective knowledge about these celestial events. By studying shooting stars, scientists can learn more about the space debris that our planet encounters as it travels around the sun. This can provide insight into the formation and evolution of our solar system, and even help us predict future meteor showers. In essence, every shooting star is a scientific opportunity, a fleeting moment to learn more about the universe we inhabit. It's a beautiful reminder that science isn't just about laboratories and test tubes. It's also about looking up at the night sky and marveling at the mysteries it holds. Through the study of shooting stars, we get a glimpse into the vast and mysterious cosmos. Shooting stars, then, are not just beautiful, they're also fascinating from a scientific perspective. These celestial wonders, often mistaken as stars, are in reality cosmic debris burning up as they enter the Earth's atmosphere. The vibrant streak of light we see, so often romanticized in literature and pop culture, is a testament to the intense heat and friction experienced by these tiny fragments from outer space. The marvel of a shooting star is not just about its fleeting beauty, but the mystery it holds, the story it narrates. Each one is a tiny traveler, journeying through the vast expanse of space, surviving the harsh conditions of the cosmos, only to burn up in our atmosphere, all to put on a dazzling show for us. Their existence, their journey, their final spectacle, all highlight the incredible dynamics of our universe. underlining the intricate interplay between beauty, mystery, and science. So next time you see a shooting star, you'll know it's not just a star, but a tiny piece of the universe putting on a spectacular show.